Hello everyone. Today we are going to learn about properties of integers. So here there are 5 properties of integers, and those are closure property, commutative property, associative property, identity property and distributive property. You have learned these properties for whole numbers in last year. Today we are going to learn these properties for integers. Okay, we will check which all operations will obey these properties, and we will write the formulas for that. Okay, also we will check with the help of examples. Now let's start with the first property, that is closure property. Okay, so here first we will check this closure property for addition. The closure property says that if we add any two integers, we must get the answer as an integer only. Then that property is called as closure property under addition. Okay, see here, closure under addition is a plus b is an integer. Whenever we are going to add two integers, we must get the answer as an integer. That is, a plus b is equal to c, where c should be an integer. Okay, so let's check it with the help of example. Here I am taking the value of a as 5 and b as -3. Okay, so let's add these two integers and let's check what is the answer for this. Okay, so 5 plus -3. Okay, now I think you all know the rules for the addition of integers. If you don't know, you can go through my video where I had explained how to add, how to subtract integers and how to multiply and divide integers. Okay, I'll give you the link of that video in the description. So here I'll tell you in the brief, whenever we have plus sign in between, we can directly write the next number as it is, like this way. See, 5 minus 3. Okay, we will vanish this plus sign and we will directly write it the number. If we had here no sign, then we have to write here plus sign. Okay, now we have to check whether both the numbers have the same sign or different signs. Now see here, 5 has plus sign and 3 has minus sign, right? As they both of them have the different sign, we have to subtract. Even though they have told us to add, we have to subtract. Okay, now 5 minus 3 gives us the answer as 2 with plus sign, that is plus 2. Why plus 2? Because here the bigger number has plus sign, so I wrote the answer as plus 2. Okay, and plus 2 is an integer. Therefore, we can say that addition of integers gives us an integer only. Therefore, integers are closed under addition. For any two integers a and b, if we add a plus b, then we will get the answer as c, which is an integer. Okay, so closure property holds for addition, we can say. Now let's check for subtraction. Okay, so closure under subtraction means when we subtract any two integers, then we should get the answer as an integer only. Okay, so a minus b should be equal to c, where c should be an integer. Okay, now let's check it with the help of example. Here I am taking the value of a as 6 and b as 9. Okay, let's subtract them. 6 minus of plus 9. Now the rule of subtraction says that whenever we have minus sign in between the two digits, then we have to change the sign of the next digit. Okay, so here we have plus 9, so we have to make it as minus 9 by removing this minus sign. Okay, so this will become 6 minus 9. Okay, now here both of the numbers have the different signs. 6 has plus sign and 9 has minus sign. So we have to subtract. 9 minus 6 gives us the answer as 3, but with the help of minus sign. Why minus 3? Because the 9 is here greater and 9 has minus sign, therefore the answer will have minus sign. Okay, and this minus 3 is an integer, therefore we can say that subtraction of integers gives us an integer only. Therefore integers are closed under subtraction. For any two integers a and b, a minus b is equal to c, where c is an integer. Therefore we can say closure property holds for subtraction. Okay. Now let's check for multiplication. Closure under multiplication says that whenever we multiply any two integer, we should get the answer as an integer only. Okay, that means a into b is equal to c, where c should be an integer. Okay, let's check it with the help of example. Here I am taking the value of a as 5 and b as minus 4. You can take any number and you can check it out. Okay. So let's multiply these two integers, 5 into minus 4. Now the rule for multiplication says that we have to directly multiply the numbers as by assuming that they are whole numbers. Okay, so 5 fours are 20. Okay, and after that writing the answer, we have to give the sign. If both the numbers have the same sign, then we have to give the plus sign to the answer. If we have different signs, then we have to give the negative sign. Okay, now here 5 fours are 20 we have to write, and for sign we have to check. Here both the numbers have the different sign. This 5 has plus sign and this 4 has minus sign. As both of them have the different signs, we have to give negative sign to the answer. That means the answer is minus 20. Okay, and minus 20 is an integer, therefore we can say that multiplication of integers gives integers. Therefore integers are closed under multiplication. For any two integers a and b, a into b is equal to c, where c is an integer. Okay, that means closure property holds for multiplication. Now let's check for division. Closure under division does not hold. Okay, directly I am telling you here, closure under division does not hold. Why? I'll tell you. Closure under division means when we divide any two integers, we should get the answer as an integer. That means a upon b is equal to c, where c should be an integer. Okay, let's check it with the help of example. See here I am taking the value of a as minus 2 and b as 7. Okay, when I divide the minus 2 by 7, then I should have to keep this number as it is, or else we have to divide it with the help of decimal point. But then the number will be a decimal number, not an integer. If I keep it as it is, then it is a fraction. Therefore, this is not an integer, it is a fraction. Therefore, we can say that integers are not closed under division. Therefore, closure under division does not hold. Okay. So, closure property holds for three operations, that is for addition, subtraction and multiplication, but not for division. Okay. Now, let's move to the next property, that is commutative property. Now, let's see for operation addition. Okay. Commutative property says that if we interchange the place of the integers, then also we should get the same answer. See here, when if I do a plus b, then also I should get the same answer as if I do b plus a. Okay, let's check it with the help of example. Here I am taking the value of a as minus 4 and b as 6. Now I'll tell you one more thing here. Whenever we have equal sign in between an equation, this is an equation. Okay, in between we have equal sign, then whatever things are present left of the equal sign, those are called as left hand side. Okay, and whatever things are present right side of the equal sign, those are called as right hand side. Okay, so I'll first solve the left hand side things and then I'll solve the right hand side, and then let's compare the answers for both. Okay, so here the left hand side has a plus b. Now let's put the values of a and b. then I got as minus 4 plus 6. Okay, now here both of them have the different sign, so we have to subtract. 6 minus 4 gives us the answer as plus 2. Why plus 2? Why not minus 2? Because 6 is a greater number and we have to give the greater number sign to the answer. Okay, these all rules you can find out in my that video whose link I am going to give you in the description. If you go through that video, it will be easy for you to understand this video. Okay, now I got the left hand side answer as plus 2. Now let's check for right hand side. Right hand side has b plus a. Okay, so first I have to write 6 and then plus and in the bracket minus 4. Okay, as we have plus sign in between, so we can write directly as 6 minus 4. Now both the numbers has a different sign, so we have to subtract. 6 minus 4 gives us the answer as 2 with plus sign because 6 is greater here. So I got the same answers for LHS and for RHS. Therefore we can say LHS is equal to RHS. Therefore addition is commutative for integers. For any two integers a and b, a plus b is equal to b plus a. That means commutative property holds for addition. Okay, now let's check for subtraction. Commutative property for subtraction does not hold. Okay, let's check with the help of example. See here, the commutative property says that if we interchange the integers, then also we should get the same answer. Okay, so a minus b equal to b minus a if we get, then we can say that commutative property holds for subtraction. Okay, so first let's check with the help of example. Here I am taking the value of a as minus 4 and b as 6. Okay, so let's put the value for a and b in the left hand side. Okay, left hand side is a minus b. So minus 4 minus of plus 6. Now just before I told you that subtraction rule says that whenever we have any number after minus sign, that number should change its sign. So this plus 6 will become minus 6. So minus 4 of minus 6. Now both the numbers have the same sign, so we have to add. 6 plus 4 is 10 with minus sign because bigger number is here 6 which is having minus sign. So the answer is minus 10. Okay. Now let's solve for RHS. RHS is b minus a. So 6 minus of minus 4. As per the rule of subtraction, we have to change the sign of this 4. So this will become 6 plus 4. Okay, plus 6 plus 4. As both of them have the same sign, so we have to add 6 plus 4 is 10 with plus sign as greater number has plus sign. So I got the answer here is plus 10. But minus 10 is not equal to plus 10. Therefore, LHS is not equal to RHS. Therefore, a minus b is not equal to b minus a. That's why subtraction is not commutative for integers. Okay. Now let's check for multiplication. Commutative property for multiplication is a into b is equal to b into a. Okay. So let's check with the help of example. Here I am taking the value of a as minus 7 and value of b as 8. Okay. So left hand side is a into b. So we have to multiply minus 7 into plus 8. Now whenever we have to multiply integers, we just forgot the signs. First we have to multiply the numbers as a whole number. Okay. 7 8 56. Now after writing 56, we have to give a sign for that as these are integers. Then what we have to do, we have to check the signs of the integers which we have used. So here both the numbers have different signs. As both the numbers have different signs, we have to give the negative sign to the answer. If they had same sign, then we had to give the plus sign to the answer. Therefore the answer is minus 56. So we got LHS side is minus 56. Let's check for RHS. RHS is b into a. So plus 8 into minus 7. Same as before. 8 7s are 56 and both the integers have the different sign. So the answer has negative sign. So we got the answer as minus 56. and LHS is equal to RHS we got. Therefore, multiplication is commutative for integers. For any two integers a and b, a into b is equal to b into a. Therefore, commutative property holds for multiplication. Okay. Now, commutative property will not hold for division. Okay. I'll tell you here only, because as closure property does not hold for a division, that's why we can't try for other properties, because even when we divide any integers, there is no possibility to get the answer as an integer only. Therefore, we can't say that commutative property holds for division. Therefore, commutative property does not hold for division. So let's move to the next property, that is associative property. Just recall for commutative property. Commutative property holds only for two operations, that is for addition and for multiplication. Okay. Now associative property. Let's check it for addition. Associative property for addition is a plus in the bracket b plus c bracket complete is equal to in the bracket a plus b bracket complete plus c. Okay. Actually, this property is same as the commutative property, just here there are three integers, and this says that, this property says that we can choose out of three integers, we can choose any two integers to solve it first. Okay, here they are choosing this b and c to solve the first, and here they are choosing a and b to solve the first. Even there is no condition to choose the integers to solve first. Okay, if we choose any integers to solve, we should get the answer as same. If we get the answer as same, then we can say that associative for property holds for addition. Okay, so let's check it with the help of example. Here I am taking the value of a as 2, b as -5 and c as 7. Okay, so let's take here LHS sign, that is a plus in the bracket b plus c. Let's put the values of a, b, c in the formula. So 2 plus in the bracket -5 plus 7 bracket complete. Okay, so as per the rule of BODMAS, we know that we have to first solve the bracket. Okay, whatever things are there in the bracket, that we have to solve first and then go to the next. Okay, so we have to keep this 2 as it is, and we have to solve for -5 plus 7. Here -5 and plus 7 has the different sign, so we have to subtract. 7 minus 5 will give you the answer as 2 with plus sign, because 7 is greater here and 7 has plus sign. So I got 2 plus 2. Okay, now both the numbers have the same sign, so we have to directly add. 2 plus 2 gives us the answer as plus 4. So LHS is equal to plus 4. Now let's check for RHS. Let's put the value of a, b, c in the bracket. So here in the first bracket we have 2 plus of -5 bracket complete plus 7. So as per the rule of BODMAS rule, we have to first solve 2 plus -5. As in between we have plus sign, so no need to worry. Both the numbers have the different sign, so we have to subtract. 5 minus 2 gives us the answer as 3 with minus sign, because 5 has minus sign. Okay, so -3 plus 7. Now both these numbers have again different signs, so we have to subtract. 7 minus 3 gives us the answer as 4 with plus sign, because 7 is greater number, so plus 4 is the answer. That means we got LHS is equal to RHS. Therefore, addition is associative for integers. For any three integers a, b, c, a plus in the bracket b plus c bracket complete is equal to in the bracket a plus b bracket complete plus c. Okay, that means associative property holds for addition. Okay, now let's check it for we can't check it for subtraction, because as commutative property does not hold for subtraction, that means associative property also will not hold for subtraction. Therefore, we directly move to multiplication. Okay, now associative property for multiplication says that a into b into c is equal to a into b into C. Okay, same as the addition, just check it for with the help of example. Okay, here I am taking the value of A as 3, B as -2 and C as -4. Okay, let's take LHS part, that is A into in the bracket B into C. So I'll put the values of A, B, C. Now as per the rule of BODMAS, we will solve the bracket first. Now here while multiplying, just multiply the numbers, that is 4 2s are 8, and now here both the numbers have the same signs, therefore we have to give plus sign to the answer. Therefore we got 3 into plus 8. Okay, 4 2s are 8 with plus sign. Now here both the numbers have the plus sign, so we will get the plus sign to the answer, and 8 3s are 24. Okay, so I got LHS part as plus 24. Let's check for RHS. Let's put the value of ABC. Now here we have to multiply these two numbers first, that is 3 2s are 6 with minus sign. Why minus sign? Because both the numbers have the different signs. So minus 6 into -4. Now here both the numbers have the same sign, so we will give plus sign to the answer, with 6 4s are 24. So we got LHS is equal to RHS. Okay, therefore multiplication is associative for integers. For any three integers A, B and C, A into in the bracket B into C bracket complete is equal to in the bracket A into B bracket complete into C. Okay, now as closure property does not hold for division, as well as commutative property does not hold for division, therefore associative property will also does not hold for division. Okay, so directly we will move to the next property, that is identity property. Now I'll tell you here we have two identities, that is one for one for addition and one for multiplication, and those are, here for addition we have additive identity, that is 0. Why 0? Because whenever we add any integer to the 0, we will get the answer as that integer only. Okay, therefore let's check with the help of example. Here I am taking the integer 6. Okay, if I add 6 to 0, I'll get the answer as 6 only. Even though if I change the interchange the places of 0 and 6, then also I'll get the same answer. Okay, therefore we can say that 0 is an additive identity for integers. For any integer A, if we add with 0, we will get that integer only as the answer. Okay, next identity is for multiplication, that is multiplicative identity, that is 1. Okay, whenever you multiply any integer with 1, you will get the answer as that integer only. Okay, you can check it with the help of example. Here I am taking the same integer, that is 6. If I multiply 6 with 1, I'll get the answer as 6 1s are 6. Even though I interchange the places of 1 and 6, then also I get 1 6 are 6 only. Therefore we can say that 1 is a multiplicative identity for integers. For any integers A, we will get the answer as that integer only. Okay, now let's move to the next property, that is distributive property. Okay, so distributive property, distributivity of multiplication over addition. Now this property is combined with multiplication and addition. Okay, multiplication over addition it is telling. Okay, so the formula for this is this one: A into B plus C is equal to A into B plus A into C. Actually this is very simple. If we have three integers and if we have to multiply one integer with the sum of the other two integers, then we can directly multiply that integer with the addition answer of that addition, or else we can multiply individually and then after that we can add, then also we will get the same answer. You can understand this with the help of example. Here I'll take the value of A as 1, B as -2 and C as 3. Okay, let's take LHS part. that is A into B plus C. Okay, don't get confused here. Here outside the bracket we have multiplication sign and inside the bracket we have plus sign. Okay, so let's put the value of A, B, C. So here A is 1, B is -2 and C is 3. Okay, inside the bracket we have addition. So first we have to solve the bracket. Therefore, here we have both the numbers with different signs. That means we have to subtract. 3 minus 2 is equal to 1 with plus sign. Why plus sign? Because 3 is greater here. Therefore, I'll get the answer as 1 into 1. Okay, 1 ones are 1. Now let's check for RHS part. That is A into B plus A into C. Now let's put the value of A, B, C here. See here. Now first I have to multiply A with B, that is 1 with -2. 1 minus 2 is -2 is as the answer, and A into C means 1 into 3, 1 3 is 3. Okay, now we have to add the answers. -2 plus 3. As both the numbers have the different sign, so we have to subtract. 3 minus 2 is 1 with plus sign. So I got LHS is equal to RHS. Therefore, for any integers A, B, C, A into B plus C is equal to A into B plus A into C. That's why we can say distributivity of multiplication over addition for integers holds. Okay. Now let's move to the next one, that is distributive of multiplication over subtraction. Okay. Now here we have a minus sign in the bracket instead of plus sign. Therefore, it is called as multiplication over subtraction, and overall things are same as the addition only. Okay. So let's check it with the help of example. Here I am taking the value of A as 4, B as -5 and C as 6. Now let's put this value of A, B, C in the LHS part. So here inside the bracket we have a minus sign, so we have to subtract these two numbers, but as we have minus sign in between, we have to change the sign of the next digit. That is 6 has plus sign, that way will become minus sign. So this number becomes -5 minus 6. Now both the numbers has the same sign, so we have to add. 5 plus 6 is 11 with minus sign. So 4 into -11. Now 11 4s are 44 with minus sign, because they both the numbers have the different signs. Okay. Now let's check for RHS. So let's put the value of ABC here. Now see here, first we have to multiply A into B, that is 4 5s are 20 with minus sign, because both the numbers have the different signs. Now here both the numbers have the different signs, so 4 6 are 24. So I got -20 minus of +20. Okay, plus 24. Why plus 24? Because 4 has plus sign and 6 has plus sign, so plus sign here. Okay, and in between we have this minus sign. Now as both the numbers as in between we have minus sign, we have to change the sign of the next digit. Therefore this becomes -20 minus 24. Now both the numbers have the same sign, therefore we have to add them. 20 plus 24 is equal to 44 with minus sign, because bigger number has the minus sign. So we got the answer as LHS is equal to RHS. Therefore, distributivity of multiplication over subtraction for integers holds. Okay, for any integer A, B, C, we can say A into in the bracket B minus C is equal to A into B minus A into C. Now, I have here summarized all the properties. You can go through it. Just remember that closure property holds only for 3 operations, that is for addition, subtraction, multiplication. Commutative property holds for addition and multiplication. Associative property holds for addition and multiplication. Identity property is there for only addition and multiplication, and distributive property is multiplication over addition and multiplication over subtraction. So here this video ends. If you have any doubt, you can ask me in the comment box. If you like my teaching, then please subscribe to my channel. Bye everyone.